Okay, welcome again to session 16 of the data science program. Right, so this week we entered properly hands-on with Scikit-learn. So I introduced to us Scikit-learn library yesterday, right? So at least we already understand or know the library that we'll be using for machine learning. So we are going to be diving into it. We're going to be looking at so many ML concepts, machine learning concepts, and as we are going through them, we are not going to exhaust everything in one class. It's not something we can exhaust in one class. So we're going to spread it over the remaining weeks we have. So as we are looking at the different concepts in ML, machine learning, we're also going to be picking some of the algorithms too, right, and looking at them simultaneously. So today we are going to look at linear regression, how to implement linear regression, right, in Scikit-learn, right? So next week, as we are moving, we're supposed to do linear and logistic regression, but that's actually fine. I've checked it and I see that we actually have enough time to cover everything. So next week, we're going to look at some other concepts, right, still in ML, right, while looking at implementing logistic regression. So next week, we're going to do logistic regression because I wanted to cramp everything up in this particular class, but I looked at logistic regression and there are a lot of things we needed to talk about. So I saw that we wouldn't have enough time to do that. So I just shifted it to next class. So by Saturday next week, we're going to look at logistic regression in details. And on Sunday, by God's grace, we are also going to look at or we are going to introduce new algorithms to us. So we're going to introduce us some algorithms. I don't know exactly the one we're going to do. Either we look at decision trees or we look at k nearest neighbor, right? So, but basically, just know that we have a lot to do moving forward. So, today I need us to pay attention, right? Yesterday's class was understandable, right? So we were not able to catch most of the things I said, but hopefully today's class the network will be smooth and we are going to be able to follow with what I will be explaining. Right. So before we kick off and go straight into the class, I will just quickly speak about our assignments. Right. I believe everyone has seen their grade already. So I was able to grade everything right before this class. So this assignment was supposed to be a giveaway for us. It's supposed to be a bonus questions, like right. So there's nothing technical about it. So it is just for you to watch a YouTube video, right, on linear and logistic regression and pick up some points there and then represent it in your assignment. So I was wondering why some of us were not really getting it. But I realized that the reason why most of us failed some of the question was because they didn't grasp or understand the question. Like they didn't read the question well, right? I noticed that the question that most of us failed was the question 2 and question 3. Question 1 is differences between logistic and linear regression, which is right. Almost everybody got that. So which everybody should know by now, right? The question 2 is to tell me the particular type of linear regression that was used in the example or in the use case towards the end of the video I sent you to watch. So we discussed the two types of linear regression, right? We talked about what are the two types of linear regression. Let me even hear from us because most of us didn't really understand. I don't know if we forgot the types of linear regression or we didn't just get the answer. So in the chat box, let me see answers to that question. What are the two types of linear regression that we discussed last week? I said two types of linear regression, not two types of the regression is not even two types. There are various types of regression. So what are two types of linear regression I taught us in the last class? Exactly. So this is just what the question was trying to ask for, right? The example that was demonstrated towards the end of the video, what type of linear regression was it? And it's very simple. It was a simple linear regression. It was a simple linear regression. Same thing for question 3. What are the two types of logistic regression, or what are the types of logistic regression that we treated in the last class? So let me see answers to that too in the chat. So I mentioned the types of logistic regression. So what are the two types? So it is a very basic question, right? This is a simple question that I believe I expected everybody to answer, but just some persons where I didn't just get it, but I just believe it was they didn't really understand the question, right? So but that's fine, that's fine. Most of us got it right, and I saw impressive um answers, right? Which some of us went beyond what was even asked to start explaining, which I really like when I see. So it shows effort and it shows an eagerness to learn. So yeah, that's fine. That's fine. So yeah, we have binomial, multinomial, and ordinal, right? So basically, but the most basic two is binary and multinomial. But yeah, we also have ordinal as part of it. So that is just a refresher on that. So today we are going to be going. Let me share my screen now. Let me share my screen. We have a lot to do today. We actually have a lot to do today. That's why I started right away. I actually can't wait for anybody, right? So let's see. Hope everyone can hear me clearly and my voice is not breaking. Let me be sure of that. Hope everyone can hear me and my voice isn't breaking. All right, perfect. Oh, okay, that's okay, that's okay. All right. So now I'll be sharing my screen. All right. So hope everyone can see my screen. Quick one. Hope everyone can see my screen and then we proceed. I want to be sure that we are good to go. All right. So today we are going to, I'll just basically go over what we did yesterday, right? And start from where we started, like the whole thing started, right? So yesterday we started with Scikit-learn, right? I introduced us to Scikit-learn, what Scikit-learn is, and everything. And as you can see, I've made some modifications to the outline. So we're going to be looking today. We're going to be looking. Yesterday we looked at the introduction to Scikit-learn, right? So today we're going to be starting from data pre-processing. Let me zoom in. Great. So today we're going to be looking at data pre-processing and feature engineering, right? And we're also going to look at splitting our data sets. Let me just put it here, splitting our data sets. So splitting our data sets and then building and evaluating your model. These are the three things we're going to look at today, right? So um, grab whatever it is you want to grab, your notes, your laptop, whatever, what have you, and pay attention because there are a lot of things I'm going to talk about today that are very, very key and very important, right? So let's just move on. Yeah, yesterday I introduced us to Scikit-learn. I won't really dwell much on this. So I told us what Scikit-learn is and the kind of tasks that you can perform in Scikit-learn: classification, regression, and clustering, right? So you know classification and regression are supervised, right? Clustering is what kind of machine learning um, algorithm or technique is that? What type of machine learning is clustering, right? Quick one. I need answers so we can move on. Unsupervised ML, right? So unsupervised ML. So great. So then we looked at the key features of Scikit-learn. We said it is easy to use. As we are going to be demonstrating, you're going to see how easy it is to use, right? So sklearn offers a consistent interface. So basically, you see the consistency as we move on, like in how you can implement various things and all the things we've talked about. We can implement them in a consistent manner, right? So we also talked about the preprocessing power. The Scikit-learn gives us um, pre-processing tools, right? So these are the things that you need to do to your data before you can move them into your algorithm, before you can use them to build your model. So you have to pre-process your data, and Scikit-learn enables us to do that, right? It gives us a whole lot of tools for that. And then it helps in model selection and evaluation, right? So basically, you should be able to do this because it's a machine learning library So these are the key features. So I'm actually rushing through this because we've done that already yesterday. So once we start what we are supposed to do for today, then we're going to take that slowly. So we also talked about the basic workflow in Scikit-learn. We said first thing first, you have to import the library. Yeah, so you import your necessary libraries. So you don't use Scikit-learn in isolation, right? When doing machine learning, right? You can see when we come here. Let's say you want to start a project and this is your notebook. You don't do import only Scikit-learn. First, you have to import pandas. Import pandas as PD. Import numpy as NP. Import matplotlib.pyplot as plot, right? And then these are the things you'll be working with. Like, so your data sets, once you import them, you'll be using these libraries to make sense of it and do a lot of stuff. And then you can now start importing different Sciki-learn modules. So there's something we're going to talk about, right? You don't do import Sciki-learn as, let's say, SK or something. No, nah, just remove your mind from that. It doesn't happen in Scikit-learn. So I will show you how we'll be importing several things in Scikit-learn, right? So you import the necessary libraries, right? And then after you've imported that, you will now load your data. So whatever your data set is, right? Let's assume you have a data set that you've collected, or you have a data set that you have already that you want to use, or you downloaded from the internet. You can now load it, and you know how to load data set. There's no new way I'm going to teach you because we've done the only way to load data set, which is using pandas, right? So you load your data set by using pandas.read CSV, right? Or pandas.read whatever data set, whatever data format it is that your data set is in. So once you do that, then you move on to pre-process your data. So don't allow this word pre-process confuse you, right? Pre-processing is the same thing, almost the same thing. It's not the same thing, sure, but it's almost the same thing as data cleaning. But the difference with pre-processing is that you're actually transforming your data in the same time. At the same time, you're not just cleaning your data, you are transforming it to be suitable for machine learning, for your learning, right? For the particular algorithm that you're going to use to train your data. So you are pre-processing your data, you are making it suitable, basically. So, right, so it's different from data cleaning. In this pre-processing, you also clean your data as well and then pre-process it. So it is option. The reason why you see optional here is because there's some data that you have that you don't need to pre-process it. They're just ready, straight off where it is coming from. They are ready for training, right? So, and you can see splitting data too. So it is also optional, right? We'll talk about that one later. We'll talk about splitting data and why we split our data too in during when working in a machine learning project. So once you do pre-process the data, you then split the data you've pre-processed, and then you now choose a particular model, and you choose a particular algorithm or model, and then train your data on it. So in this case, we're going to be looking at linear regression algorithm, right? And we're going to be training our data that we split on that particular algorithm so we are basically going to create a model, a linear regression model from the data that we have. So this is the workflow, and then we have evaluation. So once you've created your model, then you now have to evaluate the model performance. How well is your model performing? So, and then although you make predictions, right? This is part of the model evaluation and everything. So these 7 steps, I talked about this yesterday, but I want to go over that today. So we'll have a very good place to start. So these 7 steps. Now, if I give you your project, because I'm going to give you a project at the end of this program, which is going to carry a very, very huge weight to your entire grade. So if you do well from the beginning of this program to the end in your assignment and attendance, and you don't do well in your project, it's going to affect your entire grade. So just this later part of the program, be attending classes and paying attention. I'm going to be saying a lot of things, right? That's going to like inform your decision when working with your project and help you generally. So if I give you a project, these are the steps I expect you to follow, right? The only thing now that is not here currently that will also require you to do is what? EDA. So let's say after load data, the next thing will be EDA, exploratory data analysis, right? So it is in that EDA I would now ask you a lot of questions about your data. You do a lot of visualizations and presenting charts and insights, and also not just presenting, you also have actually write down and explain your insight and everything. So this project is going to kind of be a two-in-one project. It's going to be a data analyst project and a data science project and a machine learning project in one, because as a data scientist, you should also be able to do data analysis, right? So everything we've been doing before now, pandas, matplotlib, numpy, these are data analysis that we'll be doing. They are tools for data analysis. So we are going to be doing that in your project. So just buckle up and don't be scared. You'll be given enough time for your project. You actually be given enough time to do your project. So that is not going to be an issue. So once you finish this project, rest assured that if you do this project, if you take your time to finish this project, you would actually be very confident in your ability. So I think that should be the most important, one of the most important aspects of this program, the project. So you should take your time and do the project very well, right? So that's just by the way. So because of time, let's just go. So these are the things I would expect you to follow. So I told you I'll include EDA here, right? So let's just move on. Now, I told you that you don't just import Sciki-Learn as you import pandas or PD, right? Or as you import NumPy and as you import, right, other libraries. Now, the way you import Sciki-Learn is based on what you want to use. So the thing that you want to do in Sciki-Learn will inform or determine what you will import, because Sciki-Learn is a very big library. It is a very big library. When you're doing machine learning projects or when you're working with machine learning libraries like Sciki-Learn, TensorFlow, PyTorch, all these things, they are very big. So you can't import everything at the same time. You have to import specific modules and specific functions that you'll be using. So I listed out some of the most important or commonly used Sciki-Learn modules here. So we have Sciki-Learn.preprocessing. We have Sciki-Learn. I think it should be model selection here, right? Sciki-Learn. Model selection, Sciki-Learn.metrics, Sciki-Learn.dataset, Sciki-Learn. So there are more, right? I just listed out the ones that are common. So these are the things that you'll be importing, and you don't just import this when you import something from it, right? So for example, now let's say you want to work on linear regression problem. So you come here and say, instead of it to import Sciki-Learn, you just say from Sciki-Learn dot linear model. So this is the particular module for linear regression and other linear models. I don't know if there's S here or not. I don't know. Okay, let me say import linear regression, right? Let me see. So yeah, that's fine. So from Sciki-Learn, this is exactly the format you import in a lot of things in Sciki-Learn. This is just it, right? You want to import something here, you would import you do from Sciki-Learn dot that module, right? From this module, import this thing I want to use, right? Let's say you want to do preprocessing now using let's say one hot encoder. You can say from Sciki-Learn dot preprocessing, import one hot encoder. So this is the pattern. This is the pattern in importing stuff from Sciki-Learn. So you have to know the things you want to import, right? Because once you are entering or doing a project, you know what you want to do. So you know the things that you would need. So if by the way you forget and along the line you remember, you can just go back and import it, right? So that is how you work in Sciki-Learn. So this is basically how it will be looking like your import. So you import everything at the beginning here, and then you start your coding as you are moving. So you can, if you forget anyone, you can just come here and say from Sciki-Learn dot import this, right? So basically sometimes you can have like 7 things that you've imported, or sometimes you can have 8, sometimes you can have a lot of them, right? So that is how you work in Sciki-Learn. So just keep that at the back of your mind, right? So these are the various modules, right? We have model selection, we have metrics, we have data set, we have pipeline, we have decomposition, we have linear model. So let's just explore a little, right? Let's just explore a little. So let's look at linear model now, right? Let's look at the things that we can import from linear model. So if we say print dir and say Sciki-Learn dot linear model, we're going to get Sciki-Learn. Okay. So we actually have to do this. We actually have to import Sciki-Learn. So this one you're not using it for. You just want to use it to check some things in the dir. We say Sciki-Learn dot linear model. So you're going to get a lot of things, right? So these are the different algorithms, linear algorithms. So remember I just taught us logistic, right? This is logistic regression here, as you can see it here, right? And this is linear regression here. So these are just the two regression that we've talked about, but we have others, right? We have basically most of these things you will not use them, it's just few of them. The other ones that are very common is where is that? So we have ridge here. We have ridge regression, and we also have so we have ridge regression, and we also have lasso. Where is lasso? Yeah, so we have lasso here. So this one is just something we're going to be talking about later on, which is under overfitting. So these are concepts that we're going to talk about in subsequent classes. But just know that these are the things that you can import from linear models. So depending on the work you want to do, you can import whatever it is that you want to import. So the same way you imported linear regression, you import logistic regression too with this same linear model. So if we change this to preprocessing, let's see all the things under preprocessing. So we can come and say preprocessing. We are going to see some things too, right? To look at some of the encoders. We have label encoder, right? We have min max scalar. We have ordinal encoder. We have one hot encoder, right? So we have standards. We have a lot of things here, basically. So these are the things that we use in preprocessing our data. Some of the things we use preprocessing our data. I think I need to stop talking fast at this point. So these are some of the things we would use in preprocessing our data, right? And you can just explore and check them out. You can as well go to the Sciki-Learn live website, and they will explain everything for you. So you can just type Scikit-learn on your Google browser, go to the first link you see, and just explore. Try to understand how these things work, right? So I'm just trying to give you an idea of how Sciki-Learn is generally. So we can, let me just, the last one. So we can also check out the metrics. We have Sciki-Learn metrics. So we have a lot of metrics here. We have a lot of them. So for different algorithms, we have different metrics. Basically, we have different metrics for classification problem and different metrics for regression problem. So all the algorithms that can be used for regression, they have the same metric. All the algorithms that can be used for what classification, they have the same metric, right? So if we learn the metrics today for linear regression, we can use it the same way we would use for other algorithms that still do regression problem. And you know what regression problem is basically? It's those problems that require you to predict a continuous variable, right? Unlike classification algorithms that you need to predict a class, or you need to predict classes, right? So basically you have categories as your label and you want to make prediction. So you use classification algorithms. An example is logistic regression. So these are the metrics you can use in evaluating your models. So there are a lot of them. You can just explore on your own. You can check them out and just figure them. So some of the things we're going to talk about today, some we are not going to talk about today. We'll look at them in subsequent classes, right? So now, Okay, before we go into data preprocessing, there's something I just want to quickly show us, this Sciki-Learn data set. So for today's class, we are going to be making use of two data sets for illustrations, right? We're going to be making use of, the reason why we are going to be making use of two data sets is because one of the data sets will be used to demonstrate pre-processing, how we can pre-process our data, right? This is just because of the kinds of variables we have in that data set. And the second data set would be for building our linear regression model, right? So now Sciki-Learn has inbuilt data sets, right? So instead of you to go and start looking for data sets, if you want to quickly learn how to do some things in Sciki-Learn, they provide easy access to various data sets. So you can quickly just go the same way we did this. You can just come here and say Sciki-Learn dot data sets, right? I think data set, there's no S there. There's a problem. Okay. Okay, so I don't know what's happening, but let's try to check something from sklearn dot data set import load diabetes. So why exactly is it not giving me this issued? Okay, let me try another stuff. From sklearn import data set. So let me come here and put data set. So I just want to quickly show the different data sets we have, right, in Sciki-Learn. So you see now, if you put that in, you're going to see we have several data sets here. So we have you can see from here we have load breast cancer, a data set on breast cancer. We have diabetes, we have digits, we have files, we have iris, we have a lot of things basically. So there are a lot of data sets that are here that you can quickly load and use to build a model, right? So for example, now we have this low diabetes here, which is here, bar. So this is what we're going to be using for today's illustration. So once we get there to the point we need to load our data, we're going to come back here and I'm going to show us how to work with data set from Sciki-Learn. So we're going to be using two data sets, as I said before, this data set and the one that we've been using ever since, which is the retail transaction data set for preprocessing. And we're going to be using this data set for our model building. So the reason why we won't be using the retail transaction, I'm going to talk about that later. But let's just proceed. So now we're going to look at data preprocessing and feature engineering. I think this was where we lost it yesterday. So I'm going to come back and go over it again. First things first, data preprocessing, feature engineering, the same thing. Don't start racking your brain about the differences. They are basically the same thing. You can use them interchangeably. So when someone asks you, have you done your feature engineering on, have you performed feature engineering on your data set, right? It's the same thing when they ask you, have you preprocessed your data set? So these are the same thing, right? So feature engineering, data preprocessing, they are basically the same thing and they're used interchangeably, right? So before I proceed, can everyone still hear me clearly? Can everyone still hear me clearly? All right, great. So perfect. So I think network is very good today. So let's proceed. Now, before I move on to the different techniques you use for preprocessing your data, right? I'm going to talk about two concepts that are very important, right? I'm going to talk about two concepts that are very important, which are fit and transform. And I say it again, fit and transform. So these two things, they should be your best friend. Like, let me just say it that way. So you should be so close to you would be so close to them like as you are going to be using Scikit-learn, because almost every time you are doing fit dot transform dot fit dot transform dot fit dot transform dot fit or dot, so basically you'll be using this every time, right? So yeah, so basically you need to be comfortable with it. So before we proceed, I'll just go over it and explain what these two things are. So first off, these are actually methods. So I don't need to explain what methods are, right? Methods is what, can someone tell me what methods are? To be sure that we are following and we understand what it is. Can someone tell me what methods are? I'm waiting for a response. We did this, and in I think few classes ago, we talked about method. So, what exactly is a method? Exactly, method is a property of a data type of a particular object. So let's just put it that way. Methods are like they are functions. Exactly. Thank you, David. A method is a function associated with an object. I love that. I love how you put it. Is a function associated with an object. So different objects have different methods, as we talked about the other time. So this fit does fit and transform. They are methods, and they are methods of different of an object of objects that we're going to talk about moving forward. Keep that one at the back of your mind. Just disclaimer, also, I'm going to tell you to keep a lot of things at the back of your mind. So in case the back of your mind becomes heavy, I don't know, you have to get another one or so. So that's just on a lighter note. So basically we have fit and transform. So there are two methods for data preprocessing, basically. So what exactly is a fit method? What exactly does fit mean? So fit is the same thing as learn. Like I can just stop there and just go to transform. Like I don't need to explain any other thing. All these things are just extra jargons, right? Fit what the same thing as what learn. Learn Learn, learning something. So fit is the same thing as learn. That's just it. That chicken that we are done with explaining fit. So let's just talk about some other things here, right? So basically, the fit method is responsible for learning the parameters that is necessary for transforming your data. So let's say, because I'll talk about the different preprocessing techniques now. Remember, I told you that in preprocessing, you are also going to be transforming your data, right? You are changing your data from one state to another state. For example, now, okay, something I forgot to mention before we started preprocessing. Write this at the back of your mind, or keep this at the back of your mind. ML algorithms, most ML algorithms, or basically ML, computer don't understand text. What computer understand is numbers and numbers, basically. So when you want to train your data, or you want to train an ML model or build a model, all every data that you're going to be passing into that particular model should be a numerical data. I'm going to say it again. During training, all your data must be numerical. Any data that is string or not numerical is going to give you an error, right? So that is one thing that you need to put in mind while creating or building an ML model. You have to transform all your data to numerical data. So if you have categories, right, like that is like male, female, you have categories that are string. You have to transform them to numbers. So that's some of the things we're going to look at today too, right? Doing the pre-processing. So now, the transformation I was talking about, in this case, will transform those categories from the string to the numerical. So this is the transformation process, right? During processing. So to transform it, the this function dot fit would have to learn how to do it. So you have to use dot fit method to to show the particular function or method what your data is and how to transform that data. That is basically what fit does. So if you read there, you can see that basically it's responsible for learning parameters necessary for the transformation process, and it analyzes the data provided as inputs, right? And calculates statistics like mean, standard deviation for scaling, right? Or threshold for binning, or whatever processing technique you want to perform. So the fit just learns what you want to do depending on the preprocessing technique. And after you fitted it, you will now use transform. We're going to demonstrate this, so just relax. We're going to demonstrate it, but I need you to understand it first. So what transform does is that after you fitted it, you the method basically has learned how to transform your data. So once you now use the transform method, it will now use what it has learned now to now transform the data, to now change it into that particular shape or that particular pattern that you want. That's it. So that's basically this what these two methods are: fit and transform. So now there's something that you also need to know. You can use them separately. You can use fit first and then come and use transform. So once when you use fit, it's not going to give any output. It's just going to learn some things. And when you now come and use transform, that is when it's now going to give an output. That output is what? The transformed data, right? So I'm laying emphasis on this because I understand how important it is moving forward. So all these things are just to give further explanations, right? So basically, I've explained what it does. So now, um, okay, this is telling us when to use fit and transform. So basically, it's common practice to use fit on training data to learn the transformation parameters, basically, and then use the same fitted transformer objects, right, with the transform method on both the training data and the testing data. So we'll talk about these ones. I've explained it, but we're going to illustrate them. So now there's something else. I told you can use fit separately and transform separately. You can also use two of them together. So there's a method that is called fit transform. See it here. Fit transform. So the Scikit-learn provides us separately, and Scikit-learn also provides us together. So fit and transform, what it does is that it does this two step in one step. So it does the two of them together into a single step. So that's just it for fit and transform. And there are a lot of special use cases where you prefer to use fit transform, and sometimes where you prefer to use just fit and then use transform later on. So and this particular fit transform is particularly useful when you want to perform the transformation in one go. You just want to do it, right? So in using fit separately and transform separately is when maybe you want to just learn something now, but you don't want to transform immediately. So you can just learn it, and as you're going on in your notebook, you now use transform for this one, for this training data. You can now go on again your notebook, you can now use transform again. So you can be using transform as many times as possible because you've already fitted it, you've already learned how to transform it, right? So if you use fit transform, it's something you can do just once, just do it once. So those are the differences, right? So you can see a table here that summarizes everything for you. So once you get this notebook, please ensure to go through it. It will give you a whole lot. As you can see, these are the three methods that we talked about. We talked about fit data, we talked about transform data, and we talked about fit transform data. So the purpose of fit is to learn transformation parameters from data. For transform, it applies the learned transformation to new data. And then the fit transform, it combines learning and applying transformation. So modification of data, fit doesn't modify your data, it just learn, right? Transform, yes, it modifies your data and gives you a new output, a transform data. The same thing with fit transform, it gives you an output too. So this is just a summary of these two different methods, right? So now we're going to be looking at the different Scikit-learn feature engineering techniques. So if I say feature engineering in one place and I come later and say preprocessing, as I said before, it is what? The same thing. No need to bother yourself about the notation at this point. So it's the same thing. Feature engineering, the same thing. Preprocessing, the same thing. Unless you have a differing opinion, but basically that is how it is used in machine learning community. So Scikit-learn provides us with several pre-processing techniques, right? So we're going to be looking at them one after the other. So first of all, you need to know something. As I said before, machine learning algorithms doesn't accept strings, so you have to convert everything to numbers, everything. So now the first pre-processing technique we're going to be looking at is handling missing values. So you're going to be asking yourself or asking me in your mind, like, say we've done missing values before in pandas. We are able to handle missing values using drop NA or drop or fill NA, right? So we've done it. So why are we now coming to Sciki-Learn? So Sciki-Learn actually has its own way of handling missing values too. So these are actually two options. That's one thing I like about Python. There are different ways to do the same thing. So there are actually different ways to do the same thing. So, but I'm going to show you how to undo missing values, right? In Scikit-learn. So for deletion, you can just use your pandas drop NA, like straightforward. Just drop every, if you want to drop all the rows that I have, you just drop it. There's no special way to do that. You just drop it basically. So and you need to know something that what informs your choice of dropping, that is deleting data, or filling that data with new values. One, okay, the main thing is if you have a lot of data, like let's say you have like 100,000 records or rows, you can easily drop rows. If you have like 50 missing values, you can just drop it. It's not really affect your data like that. So it's very, very okay to drop it. But if you don't really have plenty data and what you are trying to do requires almost all the data that you can get, then you can't afford to drop anything. You should now look for ways to change or replace the values, the missing values, with so many things, right? So as I've touched it before, I don't really need to go deep into how to treat work with missing values. So you can use the mean, right? You can use the mean, you can use median, you can use mode, right? But mostly what we'll be using since is mean. We'll be using mean. So we're going to look at what we call simple imputer. Simple imputer. So keep this one. Just be noting all these things. These are the things that you'll be coming across with when working or doing machine learning. But the simple imputer is how the particular class you'd be using in handling missing values. So something that I also need to point out, you might have been looking at all these things I've been writing here. Let me come to this notebook and say Sciki-learn.impute import simple imputer. So you notice something at this point now. Most of these things were important. They have one kind of pattern, right? Like they have capital letters, like each word is starting with capital letter. So let me just take a few minutes to explain what this is. Now in Python, let me come here. I really hope we cover everything we want to cover today. So in Python, yeah, I think someone already knows what what it is already. That's good. So in Python, we have two kind of cases in Python. We have what we call snake case, and we have what we call camel case. So this is snake case. This is how snake case is. Everything is a small letter. Like this load diabetes now. This load diabetes is a snake case, right? Everything is a small letter and is separated by underscore. Why camel case is like this? There's no underscore, but each word in that particular this thing starts with a capital letter. So these ones now that you have here, they are camel cases. So they all have a meaning. when we use, or when Python uses camel case, it has a meaning, and when it uses snake case, it has a meaning. So snake case are usually for functions and methods. They're usually for functions and methods. So almost all the functions we've been talking about before, they are usually snake cases, right? If you can remember all the functions we're talking, they're snake cases. They are all small letter. But now camel case is for what we call class. Is for class. I don't know. Did we talk about class? I remember there's one time I talked about object, class, attributes, and method. Did we talk about class anytime in in our classes? Class rep. Can you remember Chukwudi Yusuf? Have we talked about class? Okay. Okay. Yesterday briefly. Okay. Okay. So yeah. So I'm just going to say a little about class again. So now for class are basically um, blueprints of for objects, right? Classes are usually blueprints for objects. So we can have for now we have different objects in Python. So each object belongs to a class, right? So a class, now I don't want to go into deep because there's a particular aspect of Python that is called object-oriented programming, when you have to create classes and then create objects and define the functionalities of each object. So each object in Python has a class. So a class is what you use to create objects. So just say it that way. So let me put it here. A class is used to create objects. So you can actually read more on class. So because of time, I won't really go deep. So just know that a class now is what is used in creating objects, and each class has sets of attributes and functions, right? So whatever object that is created from that class would inherit all the attributes of that class, all the functions of that class. So just understand that. So because that's how we are going to be working in Sciki-Learn. So it is not like what we've been doing before, but although it is very, very straightforward and simple, as you're going to be seeing. So all these things we are importing here, linear regression, one-hot encoder, simple imputer, they are all classes. So for us to use them, we can't just use them directly in a sense, right? Because some people use them directly, but you have to create an object from that class and then use that object to do what you want to do. That is how we work in Sciki-Learn. You import a class, right, that you want to use for something. You then instantiate that class like an object of that class. So basically, it's just like this. So I've imported simple imputer here that I want to use. So to use the simple imputer, how we're going to do it is just come here, right? Let me just create another one here. I'll come here and say handling missing values with simple imputer. So to use simple imputer, what I'm going to do, I'm just going to create an object of that class. How do I create an object? The same way you create a variable. The same thing. Exactly. The same way you create a variable. So I can just come here. Someone is already giving us some concepts in OOP, object-oriented programming. That is good. So probably you already have an idea of that. That's great. So to create an object of that class, the same way you create a variable, you can just come and name it anything you want to name it. I can just say impute, and then say equal to, and then say simple imputer. I'll now call the class, and you must put brackets. You must put brackets here like a function. So this is how you create. What I did here is creating an instance of simple imputer. So what I did here, just created an instance of simple imputer. So if I come here and say impute, okay, I think I have to import it first, and then so if I create an object of simple input and I run input, this is what I'm going to get. So basically, it's showing you what it is, right? Simple inputer. There's a class. This input is a class of what simple inputer. So if I let's see if we can put the question mark. So the question mark would give us what it means. So you can see univariate imputer for completing missing values with simple strategies. Basically just give us everything that is there basically. So that's it for working with classes and objects in Sciki-Learn. So now let's go back to our preprocessing. So in this case, we want to fill in missing values. So let's first import our data. So let's import our data. So let's come here and say df report to pd.read csv retail transaction.csv. Right, so come and say, just quickly do some quick column equals df columns string dot lower. And I'll come and say I want to change the discount name, rename. So the discount, so I'll come and say discount applied, right? And then come and put discount. So I want to change a lot of columns here. So let me just quickly say df.columns. So if I convert them to small letter, what I'm going to have here, right? I'm going to have unchange transaction dates. I don't need it, so I'm going to drop that one. So I can come here and say df.drop and say transaction date, and then I would say axis equal to 1 and say in place equal to true. So just make sure that once you write a code for dropping a column, don't run that cell twice. If you run it twice, it's going to give you an error. So make sure you do everything you want to do before you run that cell. So I'll come and rename. I want to rename some columns. So to be easy, I can say product category. I want to rename it to. So you can also rename multiple columns at the same time. I don't know if you've done that. We can actually rename multiple columns. So you just use a dictionary. The key would be the original name and the value will be new name. So you can do that. You know how to create a dictionary. So each item, this one is one item. Each item will be the former name and the new name for each column. So if I want to have many columns, I can just put comma and have as many columns as I want. So in this case, I want to change to category, right? So I want to come here and rename payments method. I want to change payments method to method. I just want to make it smaller, right? So everything will not be so cluttered. I want to change product ID, right, to product ID. I'll change it to ID or say prod ID, right? So I'll just close my dictionary and then close my function. So I can also drop multiple columns at the same time with passing them into a list. I want to drop the customer ID column because in my machine learning, like I don't need ID for anything. But I'm not going to use this particular data set for machine learning, but I'll still take you through how we're going to approach it. So if I run this cell, you see that I've done a lot of cleaning there. I've changed the column. I've renamed them, right? But something that I missed here now I didn't put in place. So in place true. So I have to do that. So I have to come and rerun this cell. So just what was going to happen. Now, if I run this, it's going to give me an error because what I've already dropped a column before. So you can see here it's telling me that transaction date, blah blah blah, not found. So that's why I was telling us before. So make sure that, so I have to just rerun it again, or I can just bring everything to the same column, put everything in the same column, right? So if I run it, everything will run again. So if I run it, everything will run again without error. So you just need to know different things to be able to work your way around. Python is very easy, like very, very easy. Once you know functions and a lot of things, it's going to be easy for you. So we've done that. So I can just come here and say display df.head, right? I just want to see my data frame basically, so I can see we have five, 6 columns, and we have some categorical variable here, right? So I want to know if there are missing values basically. So I want to know if they are missing values. So I can come and say checking for missing values, right? So um to do that, you just use your normal pandas is NA and say sum. So to give us missing, so you can see almost all columns here have missing values. Right? So product ID has missing, quantity, price, method, category, discount. So we're going to look at how we will fill in our missing values for this numerical data. So for price, quantity, discount, right? So this category method and project are categorical variables. So let's just go about that. So now what I want to illustrate is how to use simple imputer, right, to handle missing values. So now we already have our data frame, and we've just cleaned it, and we have missing values. So first thing to do, import your simple imputer as we've done here. From Sciki-Learn input, import simple imputer, and then create an object of that simple imputer by assigning it to a variable. That is just how you create an object of a class. So now there's a parameter. Each of these class that we have, that we're going to be working with, they have parameters that you can pass into this thing to define how they would work, right? So they have parameters. So simple imputer has a parameter that you have to specify. So there's a parameter called strategy. So strategy basically is going to be telling this simple imputer how to fill the mean or the missing value, how to fill the missing values of your particular data. So how I want to fill my missing value is by replacing the missing values with my mean, right? With my mean. So if I want to do that, I'll just come and say mean here. So if I run this, then it's going to register that, right? It's going to register that. Let me just quickly check something. So you see here, I actually list out all the different strategies we have. So we have mean, we have median, we have most frequent, right? We have most frequent. We also have constant value. So the mean is the normal one we know, the average. The median is the middle value. Most frequent is the mode. While constant value is basically you are going to tell the simple imputer to fill all the missing values with this particular value, with particular constant value, but it's not wise to do that. So what you mostly do is to use either of these three, mean, median, or most frequent. So but for this class, we're going to use just the mean because of time. We already passed 1 hour now and we have a lot to do. So I'm just going to illustrate this. So now we've created this simple imputer function. So now how do we use it? So I taught us how we use our fit and transform, right? I explained fit and transform. So basically, so let's just come here and say using fit and transform. So is everybody still hearing me, and are you all still following? So I'm sure I'm not just speaking to myself. Okay. Okay. All right. Perfect. All right. Thank you very much. So now you've created your object. What you're going to do next is to use your feet. So I'll come and say input. First of all, let me show you something. If I say print dir input, it's going to show me all the attributes of that input. So if I come here, I can see fit. You can see fit here, right? It's a method where you can see transform. Let's go to TTT. You can see transform here, right? You can see fit transform too. So these are methods, the different methods of this input object. So I can just come and say input dot fit, and I will say my data. So now the data I want to replace missing value for first is the price. So you can't do that for all everything. So you have to do it for a single variable at a time. So I want to replace the missing value for price the same way you do for pandas. So I come and say df price. Now, there's something that you also need to note and keep at the back of your mind. Remember, I warned you before the end of this class, the back of your mind will be filled. So now we want to replace the missing values of price with the mean, right? Remember, we said the strategy we're going to be using is the mean, right? So now, something you need to note: most of these functions, they take in two-dimensional objects. Now, this particular df.price, if we come here, let's do this. We say df price dot shape rather. This is a one-dimensional object. This is a one-dimensional object, right? And most these objects, right, they take in two-dimensional objects mostly. So if you pass in this data like this, it's going to give you an error. So you see it's going to give you an error, and the error says what? About two-dimensional 1D, expected a two-dimensional container, but got what? A panda series, right? So now we are going to change that. So to change this thing to two-dimensional, what we just do is come here and say df and put two brackets. Basically put two brackets, right? And we are going to come and say dot shape. So you see it has changed it now. It's now two-dimensional. It has 1,167 rows and then one column. So now it will work, right? So this is how to change it from one dimension to two dimension by putting in two different brackets, right? So because, yeah, basically, let's not just go into that. So we do that, and then we have down, we run that. So it has fitted this data. It has learned how to transform it using the mean, right? Transformation in this case is replacing the mean, the null value with the mean. So now I can just come here and say input dot what? Transform, and then come and say df on the same data set and say price, right? So what exactly is the, okay, I didn't close the bracket. So now I told that transform always returned what? A transformed value. So this is a list, a numpy. As you can see, this is a numpy array here. So everything is integrated, numpy and scikit-learn. And I told you, there's a question I asked you, is scikit-learn built on numpy? Some of us said no, which is wrong. So as you can see here, it's giving us a numpy array, which shows you how they are connected. So it returns a transformed value, a new value, which you can pass into a variable. So I can pass into a variable like new price, right? And I can basically just have that new variable, and then I can pass it into my data frame. So I can add the colon, a new colon with this new price in my data frame. So I can say df dot new price and say new price. So if I come here and say df you see that I have a new colon, right? New price colon. It has filled all the missing value here. So if I say df dot is na dot sum, you see that new price what has 0 missing values, but price yes still has what 12. So I can basically just drop price, just say df dot drop price and say axis equals to 1, and then say in place equals to true. So I've done that, and now if I come and say df dot head, now, so this is basically the process of how you do your transformations using Scikit-learn. You use an object from a particular class of whatever transformer that you are using, whether simple imputer or one-hot encoder or whatever, and then you create one object, then you fit it into the data you want to transform, and then you transform it. After you transform it, you get a transform data, which is in NumPy array, and you can now add that data into your data frame, and you can now use it to do whatever you want to do. So this is basically the pattern that you see mostly in Sciki-Learn. So that is just it for that. So we've looked at simple imputer. So you can explore other strategies, right? You can explore mean. Because of time, we won't do that. You can explore more most frequent. That's not mode, most frequent. You can explore median. I can even explore constant value. So I'll leave that for you to do, right? So let's just move on. Let's move on. So I told you that we are using this data set because we want to show us how to transform our data. Now we're going to move on to the next feature engineering technique, which is encoding categorical features. So we've talked about replacing missing values. So now you can actually choose to use Sciki-Learn mode of replacing missing value. You can use pandas way. Anyone that is straightforward and easy for you, good and fine. So, but the one that you would mostly be doing in Sciki-Learn, although, yeah, is what we call encoding categorical features. So remember I said that now machine learning algorithms can't take in string, so you have to convert it to numerical variables. So that is what we're going to be doing here. So we have different ways to encode categorical features in Sciki-Learn. We have label encoding, we have one-hot encoding, we have ordinal encoding. Right? So these are the 3 different things, right? That's 3 different techniques we'll be using. So I'll just quickly go over them, right? Because yeah, we still have some things to talk about. So now quickly, the same way you import all these things, same way you import all this encoding technique. So I already have one-hot encoder and I'm imported here. So I can come here and say import. I can just preprocess instead of typing everything from the beginning. I'll just say copy and paste here and say label encoder, right? Come here and say ordinal encoder. So everything is a class basically. So the same process. Remember I said Scikit-learn is consistent at the beginning. So this is the consistency I'm talking about. The patterns is almost the same thing. So now we'll quickly demonstrate how we can encoding our categorical features. So from now on, just be calling all your variables features. Like that is what, remember, feature engineering. So features. So now we have this, right? So we can quickly just say df.dtypes to check the data types of our features. So you can see we have objects here, which is string. It should be string. We have objects here. We have objects here. We have objects here. So we are basically going to encode three different features here, because this, as we can see here, 1, 2, 3. We can't pass this thing directly into our machine learning model. We have to change them into numerical variables. So there are three different ways to do that, or rather, I would say there are two ways to do that. Because let me just quickly highlight this. This is also very important to know. Now, remember I said we have label encoder. We have one hot encoder, and we have ordinal encoder. So now this one hot encoder is the one you'll be using mostly. This one is used to encode our categorical features. Label encoder is used in encoding our labels. As you can see, it's even in the name, label encoder. So it is basically used for classification tasks. So when you have, let's say, a multinomial logistic regression task or a classification task, multi-classification task that has more than 2 classes, but they're in string, you have to encode it into numbers. And what you use is your label encoder, right? So let's just assume that this method now is our label in this case. Right, this method is what we are trying to predict. So let's just bring that out and say our y. So you remember, it's always our target variable is always y. So we'll just say df and we'll say method. See why I reduced or shortened the name so it will be easy for me. So I have our label here. So if I can just say y. So you can see we have it. If I say y dot unique to see how many unique, you see that it has 1, 2, 3, 4, 5, right? So it still has one particular it still has missing values basically. So we actually need to remove the missing values. So I can just say drop any because of time. I don't have time to start going through all that. So I'll just say in place equal to true. So yeah, I've dropped the missing value. So if I say n unique, you can see it's just 1, 2, 3, 4, 4 of them now. So great. So we're trying to convert these 4 labels to categories because we can't use it in our training, in the machine learning training. So to do that, we can use the label encoder. And how we use the label encoder is just create an object. You can say encoder equals to label encoder. Right. So we've created the object. We can now, what are we going to do now? Can someone tell me what are we going to do? What's the next thing to do? What is the next thing to do? Hello, is anybody there? Remember, I already told us the step when I was discussing or talking about simple imputer. So there is a step we follow. So what's the next thing we're going to do here? Let me just know if we are still following. Let me know if we are following at this point. Thank you. Thank you, Philip. Thank you, Philip. Exactly, Ayodeji, Abraham. Exactly. So yeah, I think we get it now. So basically, we are going to fit it. We are going to fit that to our data. So in this case now, what data are we going to be fitting it into or fitting it with? What data? Like you've answered Peter, so just complete it. What data are we going to be fitting it with? Yeah, you've already said we'll fit it. So what are we going to be fitting it with? Remember in the simple imputer, we're fitting it with the price because we wanted to transform the price. So what are we transforming in this case now? So what are we going to be putting into the bracket as the argument for the fit method? So what are we going to be fitting it? What data are we going to be fitting it with? What are we saying method? What are we saying? Okay, okay. All right. Let me just quickly show us. So we're going to be fitting it with our y variable, our label, because we want to what? We want to encode the y variable from these four categories into a new numerical category or numerical values. So it is the y. So we're going to show it. We'll say encoder dot fit, and then we're going to put y because we already assigned this method, payment method, to y. So basically we'll be fitting it to y. So it will see the data and know, okay, this data has cash, credit card, debit card, PayPal. So how am I now going to learn? What am I going to learn here in this case, so that when my brother transform is going to be transforming it, is going to know how to transform it, right? So we'll come and say, after we fit it, we'll now come and say encoder dot transform. Yeah. So what are we going to put in this transform now? What are we going to put in the transform? I believe this method would make this thing stick to you. So once you are going over the class again, you will never forget this that we just did now. So exactly, it is y. So we're going to be fitting into the same data. We're going to be transforming the same data that we fitted. So we're going to have y there, right? So if we run this, you're going to see it's going to give us an output, a new numpy array, the same way it did for what? Simple imputer here. Remember, simple imputer gave us when we did transform, right? So that's the same thing. Almost everything we're going to be doing is the same method. So we have to pass it into a variable. So we can say new y, can say new y, right? So basically, we can just create a new data frame for that, but there's no need. You can use this new y like that for our machine learning. But just to make you understand, we can just come and say new y equals to pd dot data frame, right? You can come and say new y, right? I will now put what? New y, right? So should give us, if I say new, give us a new data frame. So this is the same thing here, right? So if I just come and say data y y dot, okay, if I say new y, I want to like compare to the one we have, new y, and we say old y, and we come and say df dot method, right? Or we just put y there. So this is what we're going to have if we say new y. So as you can see now, this is what we did. We converted this old categorical variable to what? This new. So you can see cash is what? 0. Credit card is what? 1. Cash is 0. So credit card is in this case, okay. Okay. Okay, I don't know exactly why you missed the variables, but basically this is just how you do that. Okay, yeah. This is where ordinal encoder will come in. So label encoder, it doesn't follow a particular order. It doesn't follow a particular order. So when your label has an order to it, then you are going to need to use a different kind of encoder. So, but in this case, it's just going to map or encode each of these variable to the new numerical variable we're going to be encoding it into. So this is for label encoder, right? So we're going to look at, well, let's quickly look at one-hot encoder, because I need to show you something now so it will not confuse you. So let's quickly look at one-hot encoder. So yeah, because of time. So you can basically just come here and import. Okay, we've imported one-hot encoder. Then we can just come and say one-hot. We have our, remember we have our df.d types, right? Or let's just say df.head, right? df.head. So we want to still encode this method again, this method. We want to encode our features. So one-hot encoder is used for our features, right? So if you have features that are categorical variable, you use one-hot encoder for that. So what we will do here is just to want to encode method, right? We'll just create a new object for one-hot and come and say one-hot encoder. So you basically always use this parameter sparse output equal to false. So this is just something that you do. And then you say one-hot dot fit. So let's just quickly use the fit and transform at the same time. Fit transform, right? And then we're going to put, so in this case now we want to encode category, right? Or let's say I want to encode category. So what are we going to put in as the argument for this fit transform? What's going to be the argument here? I want us to get this. I think we've not gotten it yet, so that's why I keep asking. What are we going to use as the argument in this case? Remember, we want to fit category, right? So yeah, what I want that particular code. What am I going to write there exactly? I need that. What am I going to write there exactly? If someone can get it, like it would be, I would like it. No, okay. I have not seen the particular. You are nobody has gotten it yet. Okay, because of time, I just have to go ahead to just say it. Who keeps saying method? Okay, all right, so that's fine. So what we're going to have here is basically is just this category, because to get this category, we just say df what category. Like this is it. Like this is the data I want to put in there. That's just it, right? So it's not a strange, it's not something that you have to think too much about. I just wanted us to know if we understand this. So if I run this, I'm going to get this. I'm going to get 5 columns. Now you need to know something about one-hot encoder. One-hot encoder is a different kind of encoding. Now, for this df, let me come and say df category and say dot unique. Why did we use y? You were not following. That is why you were not following, because we assigned the data here to y, right? So the y is not the variable now. Remember, I was trying to illustrate y as the label because it's label encoder. So we put y here because we've assigned it to the variable. So basically, when I asked us the same thing here, and I told us that I want to transform the category, so you should just know that we should put in the df category colon in the brackets as a parameter of the argument. So in this particular category, we have 1, 2, 3, 4. Okay, so we keep having any, and let me just continue using the method. Let me use the method because of time. I don't want to start. So we have okay, I think At this point, I'll just choose Y. Okay, um let me quickly remove this thing, drop df method or df dot drop na and say in place equal true. All right. Okay, so we have the unique values, right? Clothing, home decor, electronics, and books. So we want to do one hot encoding. Now, one hot encoding is different. It usually creates different columns for the different categories. So if we do one hot encoding, we're going to have one, two, three, four columns. That means we are adding four new columns to what we already have, right? And in each column, we're going to have two possible values, either what, 0 or 1, right? So just follow me here. So one hot encoding would create the number of columns that corresponds to the number of categories we have, right? And in each column that we're going to be creating, we will have two possible values, 0 or 1. So now if I come here and okay, so I have showed you the unique values, right? So let me quickly do. So this is the one I just run the one hot encoding fit transform and it gave me this output, right? Right. So if I give this into a variable, I can say new category and just say new cat. And just right. So I can just come here and say new cat dot shape. You can see that it has what, four new columns, right? So instead of in label encoder, it will just encode it and give you one column that has each this thing corresponding to the label that we have there. So but in one not encoding, you are going to have four new features. So let me just convert it to a data frame. So we have okay, just give me a minute. Think there is I there's a particular this thing you put here, set output to panda. So this I'm just trying to make it easy for us to get a pandas data frame. So set output take composition of the number two we're given. So think um just give me a minute or so we'll figure that one out. All right, so I'll get back to you on that. But basically, we'll just have to do it the manual way. But there's a way we can automatically set the output that this one hot encoder that would into a data frame basically. So we can just create a data frame here and say new. Because this one I'm trying to create a data frame for so we can visualize it well. So, but from what we are seeing here, we're having four new features basically. So, but it's going to be hectic creating this thing. So, just trying to consider time at this point. You know what? Let's just leave that. Let's quickly wrap up with the remaining ones that we have. But just understand the output of this one hot encoder. It is different. So what we have here now, the reason why we have just one here is because this particular one corresponds to. Let me bring this tf dot category dot head. So now this is the first this this is the first label, right? This is the second one, this is the third one, right? And our unique values in this particular category, we have four of them, right? So let me also bring out the unique value here. Print df dot category dot unique. So we have clothing, home decor, electronics, right, and books. So now we have I'm like it would have been better if I can just set this output to a pandas data so we can visualize it better. But I will get back to this. So once we're done, I'll remember exactly the method. But just keep a pause on this at the moment. So I'm just trying to consider time now. So we've looked at label, we've looked at one hot encoding. So now you just have to know that one hot encoding basically results in a dummy, in a kind of it creates dummy variables basically, right? So these are the things that the problem that you would encounter with one hot encoding, which I'm going to leave for now. So once we come back to it, we're going to talk about that. So let's just go to the next one that we have here, which is ordinal encoding, right? So we have ordinal encoding. Now, what ordinal encoding does is that it assigns the same thing the other encoder does. It's the same thing this one do. It assigns numerical values, right? But in this case now, it reflects the order of the categories. So this is actually quite different, right? Because if there's an order to your label, let's say your label output is let's say small, medium, and large, right? So you need to preserve that order while you're encoding. Remember in the label encoding that we did before, it was kind of scattered, right? Because we didn't preserve the order of the category. So it encoded it generally. So but ordinal encoder preserves the order of our categories. So in this case now, we basically specify some argument or parameter why instantiating the object for this ordinal encoder. So just quickly do that, illustrate that. I can come and say odd encoder and say ordinal. Remember we've imported it already. Ordinal encoder categories. So I'm basically assigning the categories to a variable. So I come and say print categories. So it's going to print the categories for me. So in this bracket for ordinal encoder, you would have to specify the categories, right? So categories is equals to what? Categories. So just to make that not confusing, I'll change the name to labels. Label, right? I'll change this to labels, and I'll change this to, what is that? Labels. All right, so I run this and I come here and I run this. So basically I've created an object, an ordinal encoder object. So I can just come here and say odd encode dot fit transform. So remember we can use the fit transform at the same time. I will put So in this case now, I'm trying to encode this categorical, the categorical variable. So let me just print that out. So display the output. Output. So I want to encode this category, right? This variable. So what is going to be in my data here? So just for time's sake, I'll just put in the category here, del.category. So please just take note of this, like what you pass into the fit transform or the fit or only transform method is the data that you want to transform. So if I run this, or transform, I'm getting it right. String. Okay. Um, okay. I've seen it. The original string. Okay. I've seen it. Yeah, thank you. So fit transform. So for this my category now, I'll just have to convert it to um what is that? I have to convert it to a list. So I'll come and say labels and say list labels. So what is the problem? Um, let's see. Let's remove this first. Let's see if there's a problem. Okay. Okay, I think I know where the problem is coming from. It's from that particular label. So I'll just have to create a manual list of our category. So print the labels first and then create a manual list. So I think it's data type that is giving the issue there. So creating decor electronics. Right. So let me try again and put categories and say lay categories. Oh God. I don't know. I don't want this thing to take our time. And this shape mismatch. If category is an array, it has to be of shape and features and features. Okay, and features. So let's just see. So in case you face problem like this, you can just easily um come here and say ordinal encoder, so you can get more information about it. So we have categories auto, we have data type, we have this. So come here, we have our categories. So we have lists, right? So category high holds the category expected in the height. Okay. The password should be units of string. and should not be sorted in case of. Okay. All right. So let's see. Equals to this doesn't work, then we'll just have to move on, and let's say in the subsequent class, or if we can, if I can remember exactly what the problem is before the class, and then we're going to do that. So, just because of time, let's not just dwell much on this. So this is very much expected. Like in during your preprocessing, you face a lot of problem, and it's very um necessary that you know how to approach them. So in this case, it's not an issue. It's something that can be resolved, but I really don't want us to spend much time on it. So, but basically, we've been able to show how to encode different variables. So if we remove that, and we just come here and fit our data, we're going to get a list here of the categories that have been fitted. So we can pass it to a variable and say ordinal category, right? And then we can come and pass it to our data frame and say odd odd cat and say odd cat. So we'll just check and see that we've gotten the newly encoded variable from this category, right? So from this category. So you notice that each of the category here has the same label. So clothing here is what labeled as 1. Home decor here is labeled as 3. Electronics is labeled as 2. So if you still come here, you see that electronics is labeled as what? 2. Books is labeled as 0. So the difference between label encoder and ordinal encoder is that ordinal encoder keeps or preserve the order of the category. So electronics is labeled as 2 here. So anywhere you say electronics, it will still be labeled as 2, right? So that is just how ordinal encoding is. So it is usually preferred that you use ordinal encoder most of the time when encoding your label, your label or your target variable. So label encoder doesn't really preserve that order. That was why you saw that mismatch initially when we got the output of the label encoder. Yeah, so that is it for the encoders and the for encoding our categorical variable. So it's actually a lot. We've talked about a lot of things, right? And I just feel like you'll be overwhelmed at this point. And but I still want us to just finish up with the preprocessing technique. So we still have scaling features. So we have three basic things we'll be doing when preprocessing our data. We have the handling of missing values. We have the um, encoding categorical features, and we also have the scaling features. So these are the three things you mostly be doing when pre-processing your data. So once maybe if you don't have a categorical variable in your data, good and fine. You can just go on and use it like that, right? There's no need for encoding your variable. So for scaling features now, we need to ensure that all our features, especially numerical features, they are in the same range. They're within the same range. So now you look at your data and you see the different numerical data. Let's assume you have, if you come here and we look at our um, data. So we have you focus on the numerical data in this case. So quantity we have 7, discount we have this. So this is what discount looks like. So the numbers are not really different from quantity. So it's still within the same range. So you can see that price is a little much bigger, right, in terms of the size. So we are seeing 76, 85, 94, 81. So you actually need to ensure that all your numerical variables they are within the same scale. So there's a reason for that. Like there's actually a technical reason for that. So it actually helps your algorithm to run faster because one particular feature is not bigger than the other feature. So it makes there's what we call convergence during training. So it makes convergence faster. So it's always advised that you scale your features. So assuming that you have maybe another feature here that is amount, right? There is amount. Like the amount can be, let's say, 100,000 naira, or let's say total amount can be like 100,000, can be 50,000, can be even 700 and something thousand. So these are huge, huge values. So when you look at compare the different numerical variables, you see that one numerical variable is bigger, is way bigger in scale than the other numerical variable. That is when scaling comes in. That is when you will need to scale your data. That is basically what scaling is. Scaling is bringing the scale of all your numerical features to be within the same range. Do you understand? So there are two ways we can do that in Scikit-learn. We can use normalization. We can use min-max scalar, right, which basically normalizes your data. So we can also use standard scalar, which standardize your data. So these are two different ways to do similar things. It's just that this standardization and normalization, they have different assumptions, right? So I won't really go into that, but for now, just understand that we are going to be we can use normalization or we can use standardization to scale our data. We'll look at the different assumptions as we are moving forward. But for normalization, there's what we call min-max scalar, which is the class that we're going to be using. And for standardization, we have standard scalar, which is also the class we'll be using for that, for scaling our data. So how do we do that? We use the same pattern we've been using ever since, right? So to normalize our data or to standardize our data, let's say we want to normalize our data now. Normalizing. So we come here and let's say we see that the price, we want to normalize everything. So quantity, discount, and price, we want to normalize them so that they will be within the same range. So I can just come here and I will say normalizing our data. And then we've imported, okay, let me see, we've not imported that already. So I'll come here and import from Sciki-learn dot preprocessing import min max scalar, and then you do the same thing for standard scalar, and come here and say standard scalar. So we've imported it. As you can see now, we imported a lot of things, right? We imported about we imported about 7 different classes. So these are you usually import in Sciki-learn. So at the end of your project or your work, you have a lot of imported class and functions and what have you, right? So unlike pandas, I just import pandas at once, right? I import numpy or import matplotlib. It's not the same thing for Sciki-learn. So based on what you want to do, you would go there and just import it like that. So we import your standard scalar. So normalizing and standardizing our data. All right. So we want to create an object for our min max scalar. So you can just say min max, or we'll say norm, right? I'll come and say min max scalar. So there's something we can add here as a parameter, which is called feature range. So this feature range will basically tell, as you can see here, it will tell our min max scalar the range we want to put our data in. So normally the default range is 0 and 1, right? But we can say we want our data to be between 5 and 10, right? But let's just leave it as 0 and 1. So we'll say okay. And we can now say norm dot fit. Okay, I'll just list out our numerical variables now. Say df dot d types, right? We have quantity, we have discount. So let's start with price. So I can come and say norm dot fit transform, and I'll say df price. Let me just know if we are following here. So I'm going to run this code now. I'm going to run this code and I will get an error. And I want us to tell us why I'm getting that error. First of all, let me be sure that everything is okay, because there's something I want us to min mascular. Okay, I've not run this yet. So I may run that and come here and run this. So I'll get an error now. What is the error? Why exactly am I getting an error in this case? But because I want to transform this price variable, right? That is here. So I have the price variable that has these values. I want to scale them to be between 0 and 1, right? So, but I'm getting an error, and I've gotten everything here. So what exactly? So let me just go down and okay. So first of all, this is not even the error. Yeah, this is not what I wanted us to. But there's a different error we are facing now. That error is new price. So now this is the error that I want us to decipher here. So this is the error message. So what do you think we should do here to solve this bug, to solve this particular bug? Let me see. The attribute takes 2D arrays, but you use one dimension. Okay, great. So how do I change it to a two-dimensional array? So how do I change it to a two-dimensional array? Right, exactly. So I put extra parentheses, square bracket there, right? So that's what we're going to do. And this is exactly what we're going to get. We're going to get values, a new set of values that have been transformed, right? So everything here is between 0 and 1. If I change the value in this feature range to 5 and 10, you see I'm going to get new set of values, right? I'm going to get a new set of values. If I change it to be between 100 and 150, you see. So this min mass scalar normalization basically brings our data to be between, it performs a calculation that puts our data between two ranges, right? So it kind of makes all our numerical data to be in the same scale. And that is very, very good for our ML model, right? So I come here and change it to 0 and 1, which is usually the default. So I put 0 and 1. So this is for our price, right? So this is our price scaled, right? This is our scaled price. Then I'll do the same thing. Now, as you can see, we want to perform the same transform operation on several columns, and that is where use fit and transform separately comes in handy. So instead of doing fit and transform like immediately, I can just come and just fit it first, right? And come here, and for each of the variable, I'll just say transform, and I'll come and say df dot quantity, right? Okay, this price, copy this, yeah, and put quantity. price new price. Okay, no, we actually have to fit transform every single thing. So fit transform. So we also have discounts. Discount. So come here and say discount scaled. I'll come here and say discount. All right, so we've basically scaled all the numerical data. So if we just add them and come and say df dot I don't know if I've not tried this, but let me see if you can add multiple columns at the same time. Scaled. So let me just try this right to make it faster, but I'm not sure what. Okay, so that actually not going to work. So, but I think they should fix that. Fix that. Let me see. Okay, yeah. So that won't work. So we'll just do it manually, and we'll come and say price scaled. And this. And say quantity. So this is one reason why your variable name should not be so long, because you might end up typing a lot. Discount scaled. So we basically have our new scaled variables. So we have price that have been scaled, we have quantity that have been scaled, we have discount. So these are the new variables, our new features we are now going to be using instead of this old one. So we can now drop this new price. So we can drop the old one. We can say drop and say new price, and we'll come and say discount, and quantity. Address equals to 1. In place equals to true. So we've dropped that, and now we have this new scaled variable. So as you can see now, we've transformed our data from what we had initially, right? What we had initially here, right? We have categorical variables and everything. We've transformed it to this now. So we have new variables here. We have scaled variables and we have encoded, labeled, encoded variables for your categorical variable. Although we didn't do for this and this because of time, but if you had encoded method, categories, and product ID, right, everything here would be numerical. Right, everything will be numerical. So after you've done that, you can now move on to perform or build your model. So the preprocessing takes a lot of time depending on the kind of data you have. It takes time, right? But now we've demonstrated a little bit on how you can preprocess your data. So remember I told you for the scaling, we have two methods we can scale. We have the min max and we have the standard scaler. So the same thing can be used. So you can just basically just change this to standard scaler here. I change this to standard scaler, remove this because standard scaler doesn't have this. So um basically I've modified the data. So I have to just so basically you have the idea. You change the standard scaler, create a new object, and then do the same fit transform, and then add the new column to your um, data frame, and then you can now drop the existing one and basically use this for your ML model training. So we're going to quickly show you how you can build a logistic regression model. So it is very, very simple and straightforward, and it won't really take time. So we're just going to use 5 minutes for that. But we also have other feature engineering techniques like feature binning, feature selection, feature transformation, dimensionality reduction. So these are what we are going to be doing in subsequent classes. So just keep it at the back of your mind that feature engineering is a very, very hectic process. As you can see in this particular class, right? Even like most data scientists struggle with getting very, very, very processed features. So you spend a lot of time. Like if your feature is not well engineered, your machine learning model will not be very good, right? And a lot of time is always spent in feature engineering, engineering your features and preprocessing your features. Basically, these three things I've explained now: scaling features, encoding features, right, and computing missing value, which is actually the simplest out of all of them. But this encoding and scaling, right, together with these other ones that we have not talked about, feature binning, feature selection, feature transformation, dimensionality reduction, they take most of the time when building an ML model, right? So it's not something you're going to perfect or understand at one go. It's something we spread out. I spread it out across the remainder of this of the program, so we can take them bit by bit. So today is just to introduce you to it. Definitely, as we are going to be working on logistic regression next week, I'm still going to go over this feature engineering, especially encoding, this encoding categorical variables, because it's very, very important that you know it, right? It's very, very important. So quickly going to go over the model building, right? Now, we're going to do something quickly. I told you about the data set that is built in Sciki-Learn. All right, so we're going to quickly use that now. We'll just say data. Remember, we loaded the diabetes data set the other time, so we'll just come here and say diabetes. So it's in the JSON format. I remember I said it yesterday, right? So it's a function, so you put a function there, right? It's in the JSON format. So to get the data, that is the features. You see data is a NumPy array, right? It has about I think 10 features. So you can just pass that to your X variable. So you don't need to preprocess anything. That is just it. Right? That you don't need to preprocess anything. And you can pass your Y, your target variable, which is data.target to your Y variable. So that's just it. Now, I remember when we were talking about the steps, we said that sometimes the preprocessing might be optional because your data is perfect already. Everything is scaled. Everything is numerical. So you don't need to go through all the hassle of putting your data in that right format. So if you have that kind of data that is well organized, you can just go straight to having these splits. You put them into the X independent variables and the Y dependent variables. So there's something we do, right? There is something we do before in our data. It is called splitting our data. I'm sorry, this class is going to take a long while. I said it initially, so please just hang on for a few minutes. I think by 9:15 we should be done. So I need us to cover linear regression. It's not going to take time at all. So there's what we call train test split. Remember, I'll be talking about training and testing data sets or training data sets most times. But there's what we also call test data sets. Sorry, 1915. I used the 24-hour time, so I mean 1915. That is 7:15. So we are train test splits. We are always splitting, or we are always going to split our data sets before we pass it into the machine learning model, right? So the training set is used for training the model, and the test set is used to evaluate the model's performance, right? So when we have the data set, that entire data set, we are not going to use everything for training. We have to split it because after we've trained our model, we want to make sure that our model can accurately predict data that it has not seen before. And what I mean by data that it has not seen before, data that was used to train it, right? So let's just go over that quickly. So to import the function, that particular function, we just write this code. So remember I told you about snake case and camel case. So this train test split is a function. It is not a class. So you don't do it the same way you are doing preprocessing. So you import this train test split. And when you import it, this is basically how you let's just scroll down. This is basically how you split it. So you say x train, you're basically creating new variables, and you say x test, and then you come and say y train, and you say y test. So this one should be in small letter. So these things that you have here, they are variables, right? So the output of this train test split will be 4 values. So the 4 values will be passed into these 4 variables that we are creating here, right? So the arguments we are going to have here is the x, that is the independent values, that is the features, and we're going to have the y, which is the label. So what this train test split will do is that it will split this x into x training data set. This x training is what we're going to use y training, and to split the remaining one into x test. So this one will be reserved for later when you want to evaluate your model performance, right? So, and the same thing for y train. Y train is the y data that will be used in training. Y test is the one that will be used for testing. So you would have another parameter called test size. So you can tell the function that you want the test size to be 20% of your entire data set, right? So our data set can be like, if our data set is 100,000 and we indicate 0.2, we are basically saying that we want 20% of that 100,000 data set to be for the test data set. So if you split it, it's going to split it into 2. That is 80,000 rows and 20,000 rows. 80,000 rows will be for training data set, while 20,000 will be for the test. So the training data set is always bigger than the test data set, and should be bigger because you need to give your algorithm or your model lots of data so it can understand and see enough pattern, right? So we indicate the test size, and we also put random states. So the reason why we do this is because, let me go to the next place. The reason why we do this is because we can put any number there, like we can just put 42. The reason why we do this is because this particular operation now is a random operation. So when this function splits, before it splits this data set X and Y into these four variables, it shuffles it randomly and then split it. So to make this particular operation replicable, you should indicate this argument. So this random state would kind of preserve this particular state that this split was performed on, so that when you want to redo it, you can now still put this 42 again, and it will provide or produce the same actual split that was done before. So this is usually, there are a lot of cases where you need it to be reproducible, but let's not just go into that. Just understand that this random state is just to make your code or the output of this operation reproducible. If you don't put it and you split this, if you split it now, it will give you a different value, give you different values for X train and S test. And if you do it again, it will still give you different random values. But if you put a random state, as long as you are putting in this random state and stating that particular number, it will give you the same exact values when splitting, right? So if we, I think I will have to do this again. So it will import the test string test splits, and then I would come here and split it. So I basically split my data. So I can just quickly come here and say X train dot shape. You can see that is 353, right? 353. Y X test is 89. So can you see now that our data set has been split into two, right? So if we come here, Y train and S train should be the same dimension. If I say Y train should be the same dimension. So basically that is just the data we are going to be using in training our model. So now let's look at how we can train our model. So we're going to be training a linear regression model. And how we'll do that is basically the same way you do your preprocessing. You've imported linear regression, right? So you create an object, linear regression object. So I can just say lin model and say linear regression. Yeah, I'll be done. Let me just quickly do this. So once you create the object, the next thing you do is just call the fit method on the object. The same way you do for your preprocessing. You will say lin model dot fit, and then you put X train and then Y train. So this is it. This is the code for training your model. This one line. So all these things that we learned during linear regression, all the sigmoid function, all this intercept, coefficient, this one, that one, everything is happening in this one line of code. That is it. So it is the easiest thing to do while doing a machine learning project. Training your model is the easiest part. The hardest part is preprocessing and evaluating your model. So if I run this code now, it has trained my model already, right? It was very fast because the dataset is small. But if I have a very large dataset, like 100,000 rows, it's going to take time to train it. So this is my model. It has trained the model. So I can come here and use it to predict by saying lin model, that same object, right? And say dot predict. And I'll now put X test. Remember, we preserve this S test for evaluating our model. So it has not seen this data set, right? The only data set it has seen is this S string that it was used in training. So you can just come here and put S test and then run it. It will give you a new, all these values you are seeing, they are predicted values, right? So if I come here, I have to pass it to Y pred, right? Y pred. So now to compare it with the actual Y predicted Y value, I can just use a scatter plot. I can come and say plot dot scatter and say plot dot scatter Y pred and then Y. So it should show me what exactly is the error now. Okay, sorry. Why print and um why test? Right. So this is it. Is this is the scatter plot showing us the relationship between the predicted value and the actual y value. So as you can see now, the prediction is not really strong, because if it was a very accurate prediction, it should give you a very strong positive correlation because the values are the same thing. But now most of the values are not really the same thing. That's why you are seeing a lot of values scattered around and everything. So now our model has been created, but it's not perfect. So we have to re-evaluate our model and do a lot of things to make sure that it is good. So we are going to be stopping here for today. As I said, this is a very lengthy class. And moving forward too, most of our classes will be lengthy. So I'll try as much as I can to be compressing some of these concepts, right? And preserving the most important one. So we talk about them. And yeah, thank God the video will be made available for us, right? The video will be made available for us. Like I hope I'll be able to do that this night, right? So I just want us to just pick or go through what we've done today when you get the video, or from after this class, just try to go over um what we've done and those points that you've picked, right? You can just look the concept that we've talked about up, practice. I will make this notebook available for us. I'll make the lecture notebook available for us immediately after this class so we can go through it. There are a lot of things that we've done, honestly, and machine learning is not it's not easy. That is just the truth. I'm not even going to try um to yeah, it is not easy, but it becomes easy with time and practice. So initially it is very daunting. So as you can see in today's class, like there are a lot of things that you need to learn, there are a lot of things that you need to know how to do. Even with the fact that Scikit-learn has made it easy for us to do a lot of this operation, still yet we have some things that we need to learn, right? So please, this week should be it should be a week where you go through all we've learned. Take your time, because as we are moving on, we are building on the concept we've learned, right? So you yourself go back and look at what we've done. Watch the videos, read the materials, right? And even you can even watch extra videos, external resources. Like I would send some useful external resources to us so we can look at them and just pick some things I would find useful. So in next class, I'm still going to look at we will complete this linear regression, right, and evaluating it. And I'm going to go to logistic regression, and then we'll still look at the same pre-processing that we did today, because pre-processing depends on the data we are working with. So depending on the data, we are going to have a different approach to pre-processing it. So we're going to look at that next week too, so you get comfortable with it. Like, right, I believe this is just an introduction to you. So I don't really expect you to grasp everything at once, and it's fine, right? So just take your time, let it assimilate, let it take its time to build. Yeah. So we've overshot a lot. This is 20 minutes, and I'm really, really sorry um for overshooting, right? And I hope we are going to try as much as we can to keep to time in the next class. Right. So yeah, we've come to the end of the class. Okay, so I don't know why my video is paused, right? But we've come to the end of the class, right? And you can just drop whatever it is that you've learned in the live class, share it with us, even if it's just one particular point, no matter how small it is. Let us know. Let us know exactly what you picked from the class, and you can discuss with your other classmates, and just yeah, that's just it. I wish you a pleasurable week, and I hope you enjoy the rest of your day. So your assignment will be made available by tomorrow. Yeah. So by tomorrow you get your assignment, which will also help you to practice what we've done today too. So yeah, thank you very much, and enjoy the rest of your day.